I want you to do is I want you to fill out the charts here. I want you to help me to fill out these tables. So the first one says y equals x plus 3. And we're going to use these values for x. So what happens when I use negative 4 in place of x here? Negative 4 plus 3 is negative 1. Then I'm going to use negative 3. What do I get for an answer there? 0. Then negative 2. Okay. Then negative 1. 0. And 1.
4.
Okay. Have I got that one? Okay, now take out a sheet of graph paper. We're going to graph these points. The first one is negative 4, negative 1. Now remember, this tells you how far to move left and right, and this one tells you how far to move up and down. So the first point is at negative 4, negative 1. Everybody caught up with me? Second point is at negative 3, 0. That means you go back 3, you go up or down 0. Then it's at negative 2, 1, so you go back 2 and up 1. Negative 1, 2. Zero, 3. Go left or right 0 and up 3. And 1, 4. Now I want you to connect these. And I want you to tell me some pieces of information about this graph. I want you to tell me the slope and the y-intercept. The easiest one for you to figure out is the y-intercept. That's exactly right. The y-intercept is right here. It's located at 0, 3. The slope is the driving direction. It tells you how to get from one point to the next point. Remember that I want you to give me the slope in terms of rise over run. And you're always going to work from left to right. So I'm just going to pick 2 points. I'm going to pick this point and this point. And I want you to tell me how to get from here to here. And you say you need to go up or down however many, and then over however many. So what is this? Is it an up or a down move? Up 1 and over 1. So up 1 is positive 1 in the top. Over 1 is positive 1 in the bottom. Any questions on how to do that? Okay, let's do number 2. Number 2 says y equals 2x plus 3. We need to fill out the chart. So this is 2 times negative 4 plus 3. What's 2 times negative 4? negative 8, and negative 8 plus 3 is negative 5. 2 times negative 3, and negative 6 plus 3 is 2 times negative 2, and negative 4 plus 3 is 2 times negative 1.
0.
Well, 2 times negative 1 is negative 2, and then negative 2 plus 3 is 1.
Right.
2 times 0 plus 3.
3. Is that 3?
And then 2 times 1 plus 3.
5.
Okay, back to our graph paper. Gonna graph this one. Everybody ready? First point is at negative 4, negative 5. The next one is located at and the next one, negative 2, negative 1. These are ordered pairs we're graphing. Negative 1, 1. 0, 3. And 1, 5. Connect. I want you to tell me the same two pieces of information. What is the slope and what is the y-intercept? The easiest one for you to determine is the y-intercept. What's the y-intercept for this problem? It's the same thing it was a while ago. 0, 3. Located right there. What's the slope? I'm going to go from here to here. So I'm going to go up 2 and over 1. Up 2 means positive 2, and to the right 1 means positive 1. So I want you to look at these two and tell me, let's write the equation on there with that. This equation was y equals x plus 3, and this equation was y equals 2x plus 3. So tell me what they have in common. The plus 3. And that happens to be the what? Y-intercept. So where do you look in an equation to determine the y-intercept? The number that's being added or subtracted, the constant number. What's different about the two?
One of them has a different x than the other one.
What's different? The number in front of the x is different? What do you call that number? The slope. Okay? The slope in this problem is 1. What's in front of the x? Well, honestly, there's nothing in front of the x but an equal sign, but what does it mean when you don't see a number in front of the x? 1x. It means there's a 1 there. This slope is 2. So the larger slope, what did it do to the line? Which one would you rather walk? If you had to walk up one of those lines, which one would you rather walk? Which one looks easier?
Definitely the 1, 1.
This has a slope of 1, and it looks like it's easier to walk than this one with a slope of 2. Okay? Any questions so far? All right, let's do number 3. Okay, first thing we need to do is fill out our chart. Negative 2 minus 3. What's negative 2 minus 3? Negative 1 minus 3.
Negative 4.
0 minus 3.
Negative 3.
1 minus 3.
Negative
2 minus 3.
Negative 1.
3 minus 3 is
0.
and 4 minus 3 is 1. Everybody got those recorded? Okay, let's graph. Okay, negative 2, negative 5. Negative 1, negative 4. 0, negative 3. Uh-oh, I put that in the wrong spot. Sorry. It goes right there. 1, negative 2. 2, negative 1. 3, 0. 4, 1. I need you to tell me the slope and the y-intercept. What's the slope in this problem?
The same thing as the first one. The same thing as 1.
So it's 1 over 1. What is your y-intercept? 0, negative 3. Okay? Now, here's what I want you to do. I want you to graph this line on the same grid with 3. Okay? I'm going to use a different color pen up here. I don't know if it'll show up real well, but we're going to graph this one on the same graph. So here we go. I'm going to go, watch me and follow along on your paper. Negative 4, negative 1, negative 3, 0, negative 2, 1, negative 1, 2, 0, 3, and 1, 4. So I've graphed these two together. I'm going to write the equation of the light blue line is y equals x plus 3. The equation of the darker blue line is y equals x minus 3. What did you tell me these two had in common? The slopes are the same. That's important. Tell me what the picture looks like to you.
Looks like a line.
Not the
Parallel.
Parallel. Looks like parallel lines. Those lines have the same slope. Are they ever going to touch? Never. So I want you to write yourself a note. Parallel lines have the same slope but different y-intercepts. Okay? They do not have to be opposite y-intercepts. Just a coincidence on this example. Same slope but different y-intercepts. What would happen if they had the same slope and the same y-intercept?
They'd be right on each other.
They'd be right on top of each other. It'd be the very same line. So we have to say to two things. We have to make sure they have the same slope, but they have different y-intercepts. Okay, let's look at number 4 down here. 2x minus 3. Let's fill out our table. 2 times negative 1 minus 3. What's 2 times negative 1? Negative 2. Negative 2 minus 3 is negative 5. 2 times 0 minus 3. Negative 3. 2 times 1 minus 3. 2 times 2 minus 3.
2 times 2 is 4 minus 3 is 1.
And 2 times 3 minus 3.
6 minus 3 is 1.
Okay. And let's graph these. Okay, before we graph, do you have a prediction as to anything? Let's look at these 4 that we've done so far. 4. Can you make a prediction about 4?
I think 4 is going to be parallel to 2.
4 is going to be parallel to 2 because it's the same.
Same line intercept. I mean, different line or same slope.
Same slope, different y-intercept. Okay, let's graph. -1, -5. 0, -3. 1, -1. 2, 1. And 3, 3. So if I plotted number 2 on the same grid, -4, -5, -3, -3, -2, -1, -1, 1, 0, 3, 1, 5. Is our prediction true? Are these parallel? Okay. If I showed you a picture of these 2 lines, could you tell me they were parallel? You know what parallel lines look like, right? What if I gave you some equations? Tell me about this. Y equals 1/3 x plus 7 and y equals 1/3 x minus 5. Would you consider these 2 to be parallel? The rule for parallel is they have to have the same slope and a different y-intercept. Do you believe that they have the same slope and a different y-intercept? Okay, let's graph these and see. Now, I'm not going to make a table. I think you can graph without making a table. Do you remember how to do that? How do you start the first one? Where do you go first? Well, you know beyond the shadow of a doubt that this is going to touch the y-axis at what? At 7. You know that point's on the graph, right? And then you know the slope. What's the slope? 1/3. So you're going to go up 1 and over 3. And then you could do it again. Go up 1 and over 3.
Oh, that's a table?
We're not making a table this time. We're just making a graph. We're going straight from the equation to the graph. Okay? What about the second one? What do you know about the second one? What's the y-intercept? -5. So I know it's going through that point. And what's the slope?
1/3.
So I need to go up 1 and over 3. I can apply that again. Do they appear to be parallel? Yes. Okay. So you don't really have to make a table or even a graph. You could probably just tell me if they were parallel by looking at their equation, right? Well, what if it said this? What if it said y equals 1/2 x plus 4, and then the next one says 2x plus 4y equals 6? Can you tell by looking at those 2 whether they're parallel or not? Not right this minute. Because you have to be able to tell me what the slope is in the y-intercept. What's the slope of the first one?
4/2.
What's the y-intercept?
4.
4. but I need to rearrange this one. I need to solve for y in order to be able to pick out the slope and the y-intercept. So tell me how to start that.
Isn't it
Y equals mx plus b. But what do you do to rearrange this so that you only have a y here? Subtract 2x. 4y equals negative 2x plus 6. What's next? Divide everything by 4. So it says y equals, now that's going to be negative 1/2 x plus 6 over 4, which is really 1.5. So I'm comparing this and this. Do they have the same slope? No, they don't. So they're not parallel. Not parallel. Okay? Not parallel because they do not have the same slope. Will they cross each other? That if they're not parallel, then they're going to have to cross, right? Let's graph it and see. The first one, where does it cross the y-axis? And what's its slope? Okay. Second one, where does it cross the y-axis? And its slope is, so go down 1 over 2. Since I started at 1.5, when I go down 1, I'm at 0.5. So I'm not on a perfect grid line. So are these going to cross? Yes, because if they're not parallel, then they're going to cross each other.
So are they only going to cross at that one point, or are they going to?
They're only going to cross at that one point. And a little bit later, we'll figure out where exactly that they cross. We're not today, but a little bit later we will. Okay.